Let's go the next step up. Let's say we don't have a leading coefficient that is 1. Let's say we have something significant out front here of the x squared. So instead of just an x squared, we've got a number in front of it. Well, the very first thing we want to look for is see if that a is common. Because if it is, we can take it out as a first step, and then the process just becomes like what we had before. So it won't be any harder as long as we take it out first. Sometimes it is common, sometimes it's not. We're going to look first at a situation where it's common. So let's look at several examples. 3x squared plus 21x plus 36. When we look carefully there, that 3 in front of the x squared also is a factor of 21 and 36. So it's actually common, so we can undistribute it to begin with. So 3 comes out of the 3x squared, we'll get x squared left. 21 divided by 3 is 7x, and 36 divided by 3 is 12. So we're able to factor that 3 out, and this trinomial now that's left is much nicer. It's got smaller numbers, and now it has an x squared out front. So the x squared is going to factor to x and x in our binomials in our final answer. The 3 comes down just directly. So the trinomial is what we're going to use to go into this location. So we're going to, instead of using a 36, we're now using 12 to find factors that add up to 7 that would go into this location. So 12 can be multiplied using 1 and 12, 2 and 6, or 3 and 4. 3 times 4 multiply to 12, but they add to 7, so we use a plus 3 and a plus 4 here. So our final answer turns out to be the product of 3 numbers, 3 times x plus 3 times x plus 4. So it's a product of 3 factors when we have something common. Now to check that, the check ends up being a little bit different. Sometimes people expect that that 3 distributes both of these binomials, but it really came from distributing to the entire trinomial. When we check this, the thing to remember is that the 3 is going to multiply just once. So a good strategy is to just multiply it first by what the first binomial is. So 3 distributes into x and into 3, which is 9. And then take that answer and multiply it to the second binomial of x plus 4. When we do that, we get 3x times x, or 3x squared, plus outside is 12x. We multiply, inside multiplies to 9x, and the last terms multiply to 36. So 3x squared we started with, 36 we started with at the beginning, and then the 12x and the 9x add up to the 21x, which was in the middle. So this does check. Since I did this calculation of adding 12x and 9x in my head, I was out of room, but it does work. All right, next step, or next example, we have 2a squared plus 10a squared, 2a cubed rather, plus 10a squared minus 12a. Here we have a 2 in each term because they're all even. But we also have something else. If you look closely, there's an a in every term. So we can actually take a 2a out at the beginning. So taking the 2a out, we get a squared left plus 5a minus 6. So our trinomial now becomes much nicer. Nicer numbers, plus the beginning doesn't have a number in front. So the 2a stays out front, and we're going to use a binomial times a binomial for this trinomial. So a squared goes to a and a. Then we have to think about what factors of negative 6 will give me a positive 5. Now remember, a negative 6, you need to use one positive, one negative. I started with a negative 1 and a 6 there. And one negative, one positive, so one of each. Only 2 ways to factor 6, 1 and 6, 2 and 3. With a negative on one of them, negative 1 and 6 is going to add up to a positive 5. So I'm going to use a negative 1 and a positive 6 here for my result. So again, I have a product of multiple factors instead of just 2. To check this, again, start by distributing the 2a in. So 2a times a is 2a squared. 2a times 1 is minus 2a. Then take that answer and multiply it by the last binomial. So we have 2a squared times a is 2a cubed. 2a squared times 6 is positive 12a squared. Minus 2a times a is minus 2a squared, and negative 2a times 6 is minus 12a. The first term, 2a cubed, we had up here. Negative 12a squared was part of our initial problem. And then the two terms in the middle, 12a squared minus 2a squared, they do add up to that 10a squared that we started with. So this does check. Now our last example has something a little different in it that we haven't seen yet. You might look at those terms and say, well, there's nothing significant that's in common with each term because this x squared doesn't have anything but a 1 out front and a negative. Well, that negative is significant, especially as we continue through the term. When we have a negative in front of our first term, our highest term, one good strategy is to factor it out because that negative is really a negative 1 multiplying everything. So when you see a negative in front of the x squared, I highly recommend you factor it out at the beginning. So x squared divided by negative 1, negative x squared that is, would be positive x squared. Now a 10x divided by negative 1 is going to be a negative 10x, and a negative 24 divided by negative 1 is a positive 24. In essence, taking a negative 1 out really just changes the sign of what's left. So x squared minus 10x plus 24. Now factor that 24, and we're going to look for two factors that add up to negative 10. Now because I want a negative, I need two negatives here. So positive 24 you only get from multiplying two negatives or two positives. Since I want a negative 10, I need to use two negatives. Negative 1, negative 24, that's not going to add up, right? Negative 2 and negative 12 will not work. Negative 3 and negative 8 won't work. But a negative 4 and negative 6 will. Those are going to add up to negative 10 and multiplied in positive 24. So I have a negative 1 times parentheses x and negative 4 and negative 6. Now, an alternate way to write that negative 1 is just to write that as negative x minus 4 in parentheses and x minus 6 in parentheses. So instead of writing a negative 1, you could just write a negative out front. To check that one, multiply the negative 1 to the first binomial. So we get a negative x, positive 4. We multiply the negative 1 in, and then distribute that or FOIL it out with the last term of x minus 6. So negative x squared. Outside terms will be positive 6x, inside terms are positive 4x, and negative 6 times 4 in the end is minus 24. The two middle terms are going to add up to 10x, so there's our positive 10x. We started with our negative x squared and our negative 21, which we had at the very beginning, so that checks. So again, if you have something in front of the x squared term at the beginning of the problem, look to see if there's a common factor you can take out that would make that come back to an x squared. That's your first step in taking care of something in front of x squared in a trinomial.